The study of utility theory presented in the videos in Introduction to Utility Theory, Total Utility, and Marginal Utility and Optimal Compensation is an older conception of utility theory, which assumes that utility is a cardinal measurement. Modern utility theory uses ordinal conception of utility. There are two important concepts in modern utility theory: indifference curve, which measures an individual's utility for a good, and budget constraints, which measure the limits of what an individual can consume. This video will look at the indifference curves, and another video will look at the budget constraints. The term indifference is used by economists to mean a bundle of two or more goods that gives the same level of utility or happiness or satisfaction. For example, an individual might get the same amount of utility or satisfaction from watching 1 DVD and 7 movies at the theater, 2 DVDs or 4 movies at the theater, or 3 DVDs and 2 movies at the theater, or 4 DVDs and 1 movie at the theater. In each case, all these bundles give the same amount of utility, thus the person is indifferent about which they choose. Economists rarely use charts in their analysis, but create graphic representations of the different bundles of goods. The graphic representations are called indifference curves. The curves represent bundles of two goods which give individuals the same amount of utility. Before looking at indifference curves, it might be useful to understand the structure of the graph. The horizontal axis represents one of the good. Usually it's labeled good X. The quantity of good X increases as one moves from left to right. The vertical axis represents another good Y. The quantity of good Y increases as one moves from the bottom of the axis to the top. In our example, the horizontal axis is going to represent the amount of movies that the person watches at the theater, and the amount of movies increases as we move from left to right. The vertical axis is going to represent the amount of DVDs that the person watches, and the number of DVDs increases as we move from the bottom to the top. If the combinations of DVDs watched and movies watched are graphed, the individual indifference curve is defined. One thing that's important to remember about indifference curves, that is, each curve gives the individual the same amount of satisfaction. In the graph, an individual gets the same amount of utility or satisfaction from consuming 15 DVDs and 4 movies at the theater, or 7 DVDs and 10 movies at the theaters. An economist would say that point A and point B have the same amount of utility for the individual. Notice that the utility curve is given the name U0. The name U indicates that this is a utility curve, and 0 indicates that it's the lowest level of utility for that person. The example of the utility curve in this slide is more like the way economists like to represent indifference curves. There are several things to note about how economists represent indifference curves. First, the economists rarely will identify the two goods they are discussing. They will typically designate the goods generically as good X and good Y. Secondly, they will rarely use actual numbers on their graphs, but refer to the quantity of good X as QX followed by some number, and the quantity of good Y as QY followed by some number. Further, along the horizontal axis, QX is larger the quantity of good we're talking about. Similarly, further along the y-axis, QY is, the larger the quantity of good y. One of the things we're interested in is the trade-off between good x and good y. Economists are interested at what rate individuals will trade consuming DVDs or some other good for some other good like movies. The marginal rate of substitution, or MRS, is the amount of good y given up in order to gain more of good x. In an example, the marginal rate of substitution of DVDs that's given up to consume more movies. While there are several ways to calculate the marginal rate of substitution, most economists use calculus to find the marginal rate of substitution of a given point on the indifference curve. However, the marginal rate of substitution can also be calculated by dividing the amount of good y by the amount of good x. Let's look at an example of calculating the marginal rate of substitution at point A. If the economist wanted to calculate the marginal rate of substitution for point A in our example, she would write down the formula for the marginal rate of substitution, the amount of good y divided by the amount of good x. Next, she would locate the amount of good y on the vertical axis that she was interested in finding the marginal rate of substitution for. In the example, the quantity of good y is 15. Next, she would substitute 15 into the formula for good y. Next, she would locate the amount of good x on the graph. In the example, the quantity of good x at point A is 4. Next, she would substitute in 4 into the formula for good x. Next, she would divide 15 by 4, giving 3.75 DVDs per movie. At point A, the individual gives up 3.75 DVDs per additional movie the person watches. More generally, an economist would write the marginal rate of substitution as the ratio of good x to good y. The formulas that they would be used would be written as QY1 divided by QX1 for A and QY2 divided by QX2 for point B. Let's look at another aspect of indifference curves. Economists generally assume that as individuals get more utility as the amount of good they consume increases without a corresponding decrease in the second. For example, if an individual was able to consume 20 DVDs and 22 movies, for example at point C, since the individual is consuming more of both goods, the person's utility must have increased to a new utility curve, U1, in our example. Generally, economists assume that higher utility curves produce higher levels of utility. Thus, U1 gives more utility than U0, U2 gives more utility than U1, and U3 gives more utility than U2. Once again, utility increases as we add indifference curves up and to the right of the original one.